Okay, guys, in example number 3, it says a computer randomly generates 4-digit passwords. Okay, so the password is 4 digits long. Okay, now it says each digit can be used more than once. What is the probability that the first 2 digits in your password are both 1? Okay, now let me ask you something. First off, these two events, right, choosing the first number and the second number, are they dependent or are they independent? What do you think, David? I'm sorry? They are... I can't hear you, David. I'm sorry. Independent. They are not dependent on each other because I'm not putting the number back in. I mean, I am putting the number back in. I can choose it again, right? Choosing 1 doesn't reduce the number of the choices that I can have for the next one. So what's the probability that I'm going to choose a 1 in the first spot? Arjun?
1 out of 9.
Not 1 out of 9, guys. Never forget 0 is a digit. I cannot make numbers without zeros. Okay? So what do you think it is, Ben? No. No. How many digits are there? How many digits are there? Somebody tell me, Jordan. There are 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits. One of those digits is the number 1. So the probability of me choosing a 1 in the first spot is what, Alexander? 1 out of 10. Now, if you look at your notes, the probability of 2 events happening is the probability of 1 event times the probability of the next event. Okay? What's the probability of me choosing a 1 in the second slot, Jimba? 1 out of 10. So what's the probability of both of these things happening, Miles? 1 out of 100. Exactly. There is a 1% chance that the first 2 digits are going to be 1s. Now let me ask you this. I'm going to change the problem on you. What if you can't repeat? What are the chances that the first 2 digits are 1 and 1? Chris? 0%, because I just said they can't repeat. So I'm not going to be able to get 1 and 1. But let me ask you this. What's the probability that I'm going to choose the numbers 1 and 4? What's that probability? Austin?
1 out of 100.
No. Not 1 out of 100. Let's think about this. What's the chance that the first one's going to be a 1? What's the chance that the first one's going to be a 1, Joseph? 1 out of 10. But what's the chances that the next one is going to be a 4? What do you think, Austin? 1 out of 9. So what are the chances that that's going to happen, Joseph? 1 out of 90. Excellent. Because remember, once I choose 1 and I can't use it again, I have fewer to choose from. Okay? All right. Good job, guys, and I'll see you at the last example.